Good morning, sir. Myself Rakshita. My roll number is 244G1A 05W4 from the Department of Computer Science and Engineering. I am pursuing my BTech first year in Srinivasa Ramanujan Institute of Technology. Today my topic is recursion with example program. Fibonacci sequence up to given number of terms. Introduction to recursion. Recursion is a programming technique where a function calls itself to solve smaller instances of a problem. It is particularly useful for problems that can be broken down into smaller, similar subproblems. Understanding recursion involves grasping the base case and the recursive case in function design. What is Fibonacci sequence? The Fibonacci sequence is a series of numbers where each number is the sum of the two preceding ones. It starts with 0 and 1, followed by 1, 2, 3, 5, 8 and so forth. This sequence has applications in mathematics, computer science and nature, illustrating growth patterns. The recursion concept. In recursion, a function solves a problem by calling itself with modified parameters. Each recursion call should work towards the base case, which is the simplest instance of the problem. If the base case is not defined or not reached, the recursion can lead to infinite loops or Stack Overflow. Fibonacci sequence using recursion. To compute the Fibonacci sequence recursively, we define a function that calls itself. The function takes an integer n and returns the nth Fibonacci number. The base cases are defined as f of 0 equals to 0 and f of 1 equals to 1, while the recursive case is f of n equals to f of n minus 1 plus f of n minus 2. Recursive function for Fibonacci. Below is the simple implementation of the Fibonacci sequence using recursion. Fibonacci of n if n is less than or equal to 0, return 0. n is equal to 1, return 1. Return Fibonacci n of n minus 1 plus Fibonacci n minus 2. This function first checks for base cases and then makes recursive calls for larger values of n. Notice how each call breaks down the problem until reaching the base cases. Example usage. To generate the Fibonacci sequence up to a certain number of terms, we can call the function in a loop. Here the example how to print the first 10 Fibonacci number. For I in range of 10, print Fibonacci I. This loop will print the Fibonacci numbers 0, 1, 1, 2, 3, 5, 8, 13, 21, 34. Pros of using recursion. Recursion can simplify code and make it easier to read and understand for problems with inherent recursive structures. It often leads to elegant solutions that are easier to implement than interactive. Functions can be more intuitive for certain algorithms such as traversals and combinatorial problems. Cons of using recursion. One major downside of recursion is that it can lead to high memory consumption. Functions may also have performance issues, especially with overlapping subproblems like Fibonacci calculations. In some cases, recursion can be less efficient than iterative solution, which may be preferred. Optimizing recursion. Techniques such as memorization can optimize recursion functions by storing previously computed results. This avoids redundant calculations significantly, improving performance for functions like Fibonacci. Conclusion. Recursion is a powerful tool in programming that can elegantly solve complex problems. Understanding how to implement recursion effectively is key to leveraging its benefits while mitigating its drawbacks. The Fibonacci sequence is a classic example that helps illustrate the principles of recursion and optimization techniques. This presentation provides a comprehensive overview of recursion, specifically focusing on the Fibonacci sequence. Each slide is designed to convey essential information succinctly. Thank you, sir.